Hello everyone. Today we're going to be talking about the binomial distribution and how to approximate it to a normal distribution. Okay, so I'm going to do a few examples about the binomial distribution before we move on to the approximation stuff. So the best example, I guess, would be if you're tossing a coin, say 20 times, right? So I'm tossing it 20 times. I need to find out how many heads I get. So for example, sorry, not how many heads I get, the probability of me getting 3 heads, right? So in this case, n is going to be equal to 20 because I'm tossing it 20 times. If it's a fair coin, my probability is equal to 0.5. That's if it's a fair coin. And then what we need to find, the question is x equal to 3, right? Now the first term, when I say 20 choose 3, the reason I'm doing this is because I really don't care which order I get those 3 heads in, right? So it could happen in the first 3, so the first, second and the third go that I get 3 heads in a row, or I can get, say, the first, the fifth and the 10th. So it really doesn't matter which order I get, I just need to get 3 heads. And then I have 0.5 to the 3, and then the last term will be that's supposed to be a times 0.5 to the 17. Okay, so remember this one, there's a 1 minus p term, and that becomes that. Okay, so that's how you calculate your binomial probabilities, right? So if x equals 3, x equals 4, and so on. Now suppose I had the question to find probability of x greater than or equal to 3. What I will be doing is finding the probability of x equals 3 and then add up x equals 4 all the way up to x equals 20. Now if you notice, there's quite a few terms to add up. I can do this, or thanks to the probability adding up to 1, what I can do is I can say equals 1 minus, in brackets, probability of x equals 0, so no heads at all. Probability of x equals 1, 1, and all the way up to x equals 2. Okay, so that's the general idea of how you do binomial probabilities. Okay, so now let's skip to the approximation stuff. So what I'm going to say is that in my problem, I have I'm going to show you for n equals say 10. So I'm going to start off with 10. My p is 0.3. Okay, so I'm going to show you a chart of what happens when x equals, probability of x equals 0 and all the way up to probability of x equals 10. Okay, let's see what happens. So I've written up some code. Let's run this. Okay, and that's what you get. All right. So if you can see, it's going up and then dying down. Right. So when it gets to 10, it's really, the probability is really small. Okay. So now I'm going to increase n to 30. All right. So all these ones were going 1. Sorry, I should have done 0 as well, which I completely missed. Don't forget to do 0. So anyway, going up to 30, this one, what it's going to look like. All right. So it's starting to look a bit more like a normal distribution, right? Now, if I do 100, it's really close to a normal distribution. So you can see they're closer together, and they're looking more and more like a normal distribution. So coming back here, so what I have is so in the last example that I showed you, n was equal to 100, p was still 0.3. I didn't change that one, right? From this q, or 1 minus p, is 0.7, so I'll write that out. Q is equal to 0.7. So one condition that we need to have is that np, which in our case is 100 times 0.3, which is 30, and also NQ, which is 100 times 0.7, which is 70, that they're both greater than 5. So for it to be a good approximation, this condition needs to be satisfied. And I've also seen in some places that they end up saying n is greater than 30. Okay. Now once we have these three conditions, what we can take out is the mean for the normal distribution. For the approximation. So the mean, the formula goes, is equal to NP. So, sorry, I mixed up the capital N's as simple N's, but it's NP, right? So in this case, it's going to be 30. Variance, on the other hand, turns out to be NPQ. So in our things, we will have 100 times 0.3 times 0.7. Okay, so which will be 21. Okay, and if you need the standard deviation, it's simply a matter of taking the square root of 21. Okay, whatever that turns out to be. Okay, so going back to this. So you have what we have is that graph. Now what I'm going to do is over this I'm going to plot the approximate normal distribution. So let me run this. So if you can see, I'll zoom into this a bit. The red line, if you can see, is the normal distribution. Okay, so if you look into it, it's pretty close, right? In fact, it's going almost on top of it, except some of the blue stuff is cutting it. But there you go. That's the approximate normal distribution. So yeah, as long as the conditions are satisfied, you can always approximate a binomial with a normal distribution. In fact, you should try to do that, because it's easy to calculate normal distributions when there's too many things to do. For example, when we come to this part of the example, sorry, the second part of the example where you had to do x is greater than or equal to 3, if I could have done a normal distribution, approximate with normal distribution, this part of the calculation, adding up 3 all the way up to 20, will be just one simple step, right? So we'll probably go through that in the next video, but yeah, let me know if you have questions. Thanks for watching.